Hi, we're going to talk about data collection, section 1.3 in your orange textbook. So, what do we mean by data collection? When we want to know something about a population, about a group of people, about a group of materials, for example, it's not always reasonable to test everything or to ask everybody. So imagine you work at a factory where you make widgets, and you want to test how much the widgets can hold before they break. It's not reasonable for you to break every widget. That would be counterproductive to your process. But you still want to get a good representative of every widget you send out into the population. The way we do that is with sampling. And to really find out whether or not your factory makes the finest quality widgets, we need to obtain good data, because any assumptions we make about the entire factory will ultimately be based on the statistics we find from our sample, whatever our sample will be. Because, and this is important, inferences are only as good as the data. So, how do we get good data? Our goal is actually to create a set of data that will produce a good representative of the population, and we call that being unbiased. So we want to pick a sampling method that selects unbiased data. Let's define those words clearly. A bias sampling method is a method that produces data that systematically differs from the sampled population. Repeated sampling will not correct the bias. So if we're using a system where we systematically and consistently get results that would be different if we ask the entire population, then there is something wrong with our sampling technique. Let's go back to our widget example. Say we only take widgets off of one line. Only one widget making machine is tested. Does that represent the other 100 machines you have in your factory? Or would it be better to take an unbiased sample, one where we test widgets from each and every machine? Because an unbiased sampling method produces data that represents the population, and repeated sampling will correct any bias that may exist. So let's do an example. So in 2008, NBC posted a question on their website, whether or not we should remove "In God We Trust" from U.S. currency. And as you see, 86% of the population said absolutely not. The motto has significance and does nothing to establish a state religion, which is sort of a surprising result. But it turns out, at the same time, an email was circulated to help get the vote. So you've seen these go by on Facebook or on Twitter or whatever. Let's show everyone what good Christians we are, and show NBC that what we really want is for our money to say "In God We Trust." So, send it to everybody you know, and everybody go and vote. So the question is, do you think this affected the result? What it tells us is no meaningful conclusions about the population of the United States can be drawn from this survey. And the reason is because with this encouragement by one particular part of the population, our sample turned out to be biased. And so we can't use it to speak for the American people. So let's talk about different kinds of data collection. Two commonly used ones are called convenience and volunteer samples. Convenience samples occur when someone grabs the objects or the people or the places that are most convenient to them. So say you needed to talk to 50 people about their sleeping habits. If you just stood outside on the street and asked the first 50 people you saw, that is a convenient sample. Say we wanted to talk about high school students and their preferences. A convenient sample for us would be the 20 people in our classroom. Okay, a volunteer sample is one where results are collected based on voluntary response. But both of these kinds of samples have some biases attached to them. So, for example, did you ever buy a basket of fruit at the market based on the fruit on top, only later to discover the rest of it wasn't as fresh? We trusted the convenience sample, the one that's on top, but that doesn't mean that all the fruit, that all the data is good. Have we used our class as a sample from which to gather data? That's also not as good, even though our class is convenient. So, this is a really good question. Have you ever mailed responses back to a magazine survey? So under what conditions would a person take the time to answer such a questionnaire? Think about TripAdvisor. You ever seen the ratings on TripAdvisor? Often they're terrible, because under what circumstances would you take the time to answer the survey? Most people's immediate response is to ignore a survey, unless they feel very strongly one way or another. They really loved a place, or they really hated it. But it doesn't really account for the multitude of people in the middle who had a reasonable and appropriate experience that was otherwise unnoteworthy. Okay? So how can we do data collection in such a way, other than convenience and volunteer, that allows us to get a better, unbiased sample? To do a data collection process, we have a number of steps. First, we need to define the objectives. We want to compare effectiveness of drugs. We want to find the average height of teenagers. We want to see if the widgets in our factory are strong enough. And then we need to define the variable. The drop in cholesterol, the length of time for patient recovery, income of households, the average age of drivers. We want to identify our data collection schemes. We want to decide who we're going to ask, how many people we're going to ask, and how we're going to collect the data. Then we'll collect the sample and review the sampling process. Often, at the very end, an analyst is stuck with data already collected because it's not always reasonable to choose who you ask. Think about, for example, testing a new cancer drug. You are limited to people with cancer to ask, and you can't always choose the sample you want. It is much approved to try and find a technique where you get to prove where you don't have a limited sample. So, for example, the admissions dean of our college wants to estimate the average cost of textbooks per semester per student. Please remember that the book we use is a college textbook, and so often their examples are college-based. So, the population of interest is the currently enrolled student body. Those are the people we want to know about, but we don't want to ask every student because that would be too much information and the cost of collecting that data would be too much. So the variable we want to know is total amount spent for textbooks per student per semester. So two common methods used are experiments and observational studies. So in an experiment, you control the situation. So often we use experiments when we talk about drug testing, for example. So we give half a group an experimental drug and the other half a placebo so that no one knows who's taking the real thing and who's not. And we'll talk about that more later. Okay? So if you read about a laboratory result using white rats to test blood pressure. Okay? The experimental treatments are designed in such a way that they allow us to test one variable. In an observational study, we don't modify the environment. We don't give someone a drug and see what happens. We just watch them and see what happens. You often hear about these long-term studies or observational studies. Things where they start out when they're little kids and they monitor their reading habits, and then they monitor those habits for the next 20 years. Those are observational studies. When they do toy testing, they give little kids toys, put them in a room, and just watch them. No, they don't make them play with certain toys. They just see how they respond in whatever situation they're in. The data sometimes can be obtained by sampling a population of interest, and surveys are one kind of observational studies. Because in a survey, we don't really affect what people are doing, we just have them report on the choices they've made. So if every element of a population can be listed, enumerated, which means counted, or observed, we call that a census. But we've talked about this lots. A census is expensive. It is time-consuming. It is difficult. And it's sometimes nearly impossible. In situations like this, we almost always use what we call a sample survey. So when selecting a sample for the survey, we want to use some sort of frame. So a sampling frame is a list or a group or a set of elements belonging to the population. And we want our sampling frame to be identical to the population. So the proportion of men to women should be the same. The proportion of different ethnic groups should be the same. We want to pick people of similar socioeconomic spread as the whole population. So in a case of a census, It can be a sampling frame if we include every member of the population once, and only once. But a census may not be so easy to obtain. So, lists of registered voters with the telephone directory are sometimes used as sampling frames for the general public. They will pick information at random out of a phone book, but there are some serious problems with that now. One reason is because many people are choosing not to have a landline or to have their numbers listed. That limits our population. Regardless of how we do it, we want the elements in a frame to have an equal chance of being selected, and we want that frame to be representative of the population. Okay? So, to judge this process, we want to have different kinds of sample designs in two categories: judgment samples and probability samples. So, judgment samples are selected on the basis of being judged typical. They're normal. They're reasonable. So, when you pick a judgment sample, the person selecting the sample chooses things they think are representative. That would be like me going through the room and picking 3 people and saying, I think you best represent the population. But that depends entirely on my judgment, and it's not really a valid statistical procedure, because I can't know about the population when I'm picking my sample. A probability sample is one where the elements are picked according to the rules of probability. So each element of the population has a certain probability of being chosen, and we pick from there. So there are lots of ways to design probability. There are single-stage methods and multi-stage methods, and we're going to talk about those. So the single-stage methods are things like, means we only pick once. We don't pick a group and then pick a group. We only pick once. And the most common and reasonable and easy to describe one is called a simple random sample. And a simple random sample, and a lot of times your book will call this an SRS, is a sample selected such that every element has an equal opportunity to be selected. And all samples of size n, so if I'm picking groups of 10, every possible group of 10 is equally likely to be selected. Okay? We find random samples in a couple of different ways. We find them with random number generators. We find them with random tables. Computers do a reasonable job of randomization, although it's not totally random. But inherent in the cause of randomness is that the next answer is not easily predictable. So when we draw a random sample, we have to use every effort to make sure that everyone is equally likely to be picked. You need to be careful, though, with the word random, because the human brain mistakes evenness for randomness and haphazardness for randomness. And so our tendency as people is to pick things that are sort of evenly spread out because that's random. But that's not true. Think about shuffle mode on your iPod. It does pick songs at sort of, imagine the air quotes here, random. But there is one huge issue with that, in that your shuffle mode does not repeat a song until it has finished its playlist. That is not randomness, because in randomness, every song, even the one that's currently playing, is equally likely to be picked for the next song. So if you were truly experiencing a random shuffle, occasionally you would hear the same song twice in a row. So, to carefully avoid this natural tendency to mistake evenness or haphazardness for randomness, we're going to follow a procedure to find a simple random sample. So first, we're going to identify each element with a number. Usually we do this sequentially. We just start at one end and number from 1 to whatever. And then we use the same number of digits. So if there's 20, for numbers 1 through 9, we're going to use 01 and 02 and 03 so that everything has 2 digits. Then we're going to find some way to pick those random numbers. We can do it with a random number table, which is in the back of your book, which I'll be happy to show you if you're confused. It might actually be later in the slideshow. Or we can do it with a random number generator on your calculator, or we can do it with a computer, or we can pick numbers out of a hat, All of those are acceptable methods. So let's consider something like example 11. So, employers look for positive attitude. So it says here at the top, what do employers look for in a seasonal employee? And number one for them is positive attitude and eagerness. So let's define the objectives for collecting data. The first one is, our objective is to find the opinion of employers regarding seasonal employees. Then we want to define the variable and the population of interest. The variable is the response to the question. That's what we want to know, the opinion of the employer. And the population of interest is everyone in the U.S. who hires seasonal employees. We're going to define data collection schemes. So based on the graphic, it says it came from snagajob.com. And upon some further study, they found that Public Affairs, a third-party research firm, conducted this survey on behalf of the Hourly Jobs website. It was an online survey of 1,043 hiring managers. Okay? That is our data set. They collected the sample by finding out what was their most essential. They let them only pick one. So now let's test our procedure. Since it was an online survey, were only the hiring managers that conduct their business online aware of the survey? Do you think there were other people who answered? Do you think there's people who hire but aren't online, who could have missed part of this survey? So do you think it would represent every type of country and business if we hire people at farmers markets? Do you think they have time to answer online surveys? Things to think about. So, another single-stage method is something called the systematic sampling. And this is a sample in which every kth item of the sampling frame is collected. So we put you in order and say, okay, I'm going to randomly pick every fifth person. So this actually happens to you guys all the time, because I do it most of the time at dances, which is, unless there's something odd going on, or the line gets really short, or the line gets really long, when you go to a dance, I pick every third couple and send them to the breathalyzer. Or every fifth couple and send them to the breathalyzer. Unless the line gets really long, or the line gets really short, then I'll send a couple in a row. But it is mostly a systematic sample. Okay? And if you really want to read through all the math. So if we desire a systematic sample of 3%, we would divide 100 people by 3% and ask every 33rd person. So this is in your book in detail if you want to know more about it. So, for example, a systematic sample of every kth house along a long street. So if we wanted to stop and ask every third house, that might work for example, except it might result in something disproportional to corner lots. Because if we picked every third house, we would start with the house on the corner every time. So imagine we were asking about a sidewalk tax. As someone who owns a corner house myself, we have way more sidewalks than many of our neighbors. We can tell in the winter when we have to shovel them. So this would not be a good sample for that situation. What about multistage methods? A multistage sample is one where we divide our big group into smaller groups and then choose from among those groups. Those subpopulations, that first set of smaller groups, are called strata. So a stratified random sample is obtained by separating a population into subgroups and then choosing from those subgroups. So the subsamples are summarized. So that would be like separating the population of Bishop McCourt into freshmen, sophomores, juniors, and seniors, and then picking a group from each grade. That is a stratified sample. If the strata are proportional, the stratum, things we pick from the strata, are proportional, that's called a proportional stratified sampling. That would mean if we were to school where we had 100 seniors and 50 freshmen, we would take twice as many students from the senior class as we would from the freshman class. A cluster sample is where we put people into groups and then collect all of a group. That would be if we separated you into homerooms and then took all of a randomly selected homeroom. So if we said we want to pick a quarter of the student body, we're going to randomly select a quarter of the homerooms. That's a cluster sample. The first stage is to separate you into homerooms. The second stage is to select whole homerooms. So imagine, for example, that we wanted to do some polling. And so we separated people into townships and then randomly selected townships to ask about their voting habits, but asked everybody in a township. That would be a multi-stage cluster sample. So, as you can tell, sample design is not simple. There are lots of colleges and universities that do nothing but classes on sample design. And it is a whole textbook on its own. So please read through this section in your textbook, but understand that we're only going to do the bare minimum that we can to prepare you for the test.